So, afternoon. Hey, thank you. Thank you for coming to this session, and thank you for bearing with the fiasco of the escalators. So, for all that had to go through that, for me personally, my apologies. Sorry. We're very customer obsessed, and so we're going to figure this out, and hopefully it won't be this bad tomorrow. So, give us a chance to fix it. With that said, you are in the Security at Cloud Scale session. If that's not the session you wanted to be in, here's your opportunity to hit the ripcord now and take a jump out. All right, great. Small, intimate group, we should have fun. So I'm Larry Gilreath. My official title now is Global Accounts Security Specialist SA. And merely what that means is I work with some of our largest customers to help them move those workloads into AWS in the most secure manner, and then actually transform their security teams to be more agile and move into more of a guardrail model to allow their development teams to move into a agile DevSecOps environment as well. Today, when I crafted this agenda, I thought, okay, it's a summit, there's so much going on. What do I really want to try to drive home in a short 60-minute window? Well, the more I thought about it, the more I came to a conclusion that I wanted to make sure this session was about you. So I want to start by talking about some of the controls that you inherit when you leverage AWS. Then we're going to talk about the framework that you can adopt around best practices as you move to AWS. Then we'll drive into some of the services to help you automate your security at scale and strengthen that security posture as you move those workloads into AWS. And then, of course, at the end, we'll talk about some incident response and give a reference example of what that needs to look like. Before we dive too deep in, I kind of want to get a sense of who you are. So, by round of applause, who's ever built or designed an architecture only to find out that, I don't know, let's say 6 months down the road, everything you built was way too small for the actual demand? Yeah, it's kind of that fish in that fishbowl scenario where when I built this, Mr. Fishy was happy and swimming, but as we continue to roll it out, as we continue to bring on more users, all of a sudden, he's outgrown his environment. With that, all the security controls, all the security architecture that we put around that application, they could be at risk as well. And they could have potentially be outgrown as well. And so when we look at security at scale, it's the idea of how do I put security around these workloads that will allow me to still be flexible and grow, but not put my actual workload, not put my brand, and most importantly, the data at risk as we continue to grow. This shouldn't be a surprise to you. By round of applause, who's seen this slide? All right. Okay, great. For those who haven't, this is what we call our shared responsibility model. And the idea behind this slide is when it comes to security, there's portions of security that fall squarely on our shoulders. And then there's portions of security that fall on your shoulders. And this slide is designed to denote where that potential line can be. Now, that line moves up or down depending on the service. If you start taking advantage of higher level services like RDS, you'll see that line slowly move up to consume more of the customer portion. But if we're talking about the base level services, EC2, VPCs, networking, things of that sort, that line is a good marker of where you are. We like to summarize it as we're responsible for security of the cloud while you're responsible for security in the cloud. And we like to help you get there. Let's talk about our portion of it first. 2,500. We currently apply over 2,500 security controls to our portion of the shared responsibility model. Why is that important? Well, anytime that we take the onus of a security control and we build a process or mechanism around it to address it, that's one less control that you don't have to worry about. So that's taking that undifferentiated heavy lifting, taking it off of your shoulders and the shoulders of your business and putting it on our shoulders to actually own up to it. And the beauty is when we identify the control, put a mechanism or process in place to address the control, then we can be consistent of how we apply that across all the regions. So I'll give you a perfect example. This was a hard drive. So one of our controls is to actually handle media sanitation in line with the NIST 800-88R spec. What that means is hard drives don't come into our availabilities, well, they come into the availability zone intact, but none of them are allowed to leave intact. So as we have hard drives that fail, maybe we have an abundance of them, they actually get shredded and they don't leave intact, so that way data is not at risk that was on that hard drive from someone being able to see it. This becomes important because this is a control that's defined, and then we have a process and a mechanism that we put around it that now gets applied consistently across all 16 of those regions. Now, a lot of those controls, I would love for us to stand up and say, hey, we're going to design all the controls you need and trust us on this. By round of applause, who's okay with that security model? No one. Well, that's good, because that's not how we do it. We actually leverage the actual compliance frameworks that are publicly available to you. Why does that matter? Because that means there's transparency into what the required controls are, and you can have understanding of what the requirements are, and then take advantage of our compliance reports to now see how we address that prescribed control. And there's a couple of key things here I want to talk about on this slide as well. By round of applause, how many of you see a compliance logo on here that you're unfamiliar with? Yeah, that's a good thing, because the compliance frameworks that we snap to and that we try to adhere to aren't just US-based compliance frameworks. Much like many of you work for companies that just aren't US-based, customer-driven. And so when we build those compliance frameworks, we don't only look at what the US is doing, but we also look at those frameworks internationally. And we also look at frameworks that are industry-specific. So if you catch that logo there, the movie camera, that's a framework that's been identified by the actual film and movie industry, which is great because they're very aware of the type of attacks that they get hit with, as well as what methods have been proven to work to stop those attacks and allow them to actually exchange or do what they need to do in the most secure manner possible. And so when we look at these security controls and these frameworks and say, yep, we're going to snap to this, the beauty of it is you have visibility of what the requirements are for those frameworks. Those frameworks can be international, and you have the ability now, using what we call artifacts, to actually go in and get these compliance reports. And look what our third-party auditor said in reference to this particular compliance program. Did we meet all of the controls? Are there any deviations? Why? Because if I tell you that I'm adhering to this particular model of how I go about securing my portion of the shared responsibility model, and I give you a method to actually look what a third party says in regards to how I'm applying those controls, I also put you in a position to be able to validate that we're delivering on our side of that shared responsibility model. Along with validating that we're doing our part, I also put you in a position to now tack on your controls, your portion of the shared responsibility model. So now you can actually have workloads that meet those same compliance burdens. By round of applause, how many of you have workloads that have a compliance requirement? Good, good. So we've been doing this for a while and helping customers navigate and nest our compliance report, and then also helping them turn the right knobs so they can actually build their compliance requirements. And as we successfully work with customers to do this, we like to capture all of that data. How did we do it? What roadblocks did we actually get through? What speed bumps did we drive over? And so we put it all together in something that we call the CAF, the Cloud Adoption Framework. And so this is our expertise and our learning put into a model that can scale. So anyone can download the CAF. It's publicly available now. If you go to Google AWS Cloud Adoption Framework, you'll see links to it. The key piece I want to touch on is that security perspective of it. So not only have we done this, but we've done it enough times to actually have some prescriptive guidance of how to address the actual security perspective of moving your workloads to the actual cloud. I got good news for you. Security in the cloud's really not unfamiliar. If you've played Atari, you probably can play Nintendo, and you can probably figure out how to play Xbox. And so if you have good security practices and mechanisms in place to secure your on-premises workloads, that same knowledge, that same expertise will definitely translate into how you go about securing your cloud workloads. Security in the cloud is far more familiar than what you think. There are some changes. There are some nuances in it. So let's talk about the security perspective from the CAF. Usually when the business comes to me and says, hey, I own this new development initiative. I need XYZ from an infrastructure standpoint so we can start testing. Then I have to, if I'm on premises still, I have to map out, do I have the amount of resources they need? Do I need to order something else? Do I potentially have an opportunity to leverage my infrastructure better? So on and so forth. Well, because the infrastructure is there and available to you in the cloud environment, that no longer becomes the gating requirement to come in. The gating requirement now becomes the identity and access management. What services am I going to allow them to use? Who's going to have access to those services? What can they do within those services? And the beauty of this is from our platform, everything is an API call. And so using our identity and access management, you can restrict the individual access to individual API calls. But keep in mind, for this model, for the CAF security perspective, this isn't just talking about AWS IAM. This is talking about IAM holistically. Am I going to allow federation into AWS, be able to take advantage of my existing hire-to-fire scenarios to ensure that whoever is leveraging that cloud infrastructure environment is an actual employee, or is it someone laid off, or is it someone who's waiting to be hired? And then once I figure out how I'm going to actually manage the identities, then I can start looking at my detective controls. What controls am I going to put in place? What guardrails am I going to put around these users who I'm giving access to this environment? And then from there, what infrastructure security am I going to put in place? How am I going to gain visibility into what the people that I've given access are doing with the infrastructure that I allow them to use? Then, of course, data protection. How am I going to handle encrypting data, storing data? How am I going to ensure that I have visibility of who is accessing data? And then finally, incident response. When something goes wrong, notice I said when, not if. When something goes wrong, how do I react? Who do I engage? Can I automate my response? How do I properly track all the actions to remediate? And how do I ensure that if it is an event, it's an event that we go through once, not every week? All of these are parts of that CAF security perspective. All of these are based on what we've learned. Now, when we start talking about security at scale, I was really scratching my head probably about 2 months ago. We could definitely drill into the CAF, but how does that really help make the topic stick? It's tough. So I thought about a session. By round of applause, how many of you have been to either a summit before or an AWS summit before or reInvent? Okay, great. If you haven't, I would encourage you to look for a session out on YouTube. It's called Scaling to Greater Than Your First 1 Million Users. That session walks through decoupling, taking advantage of auto-scaling groups, leveraging or making the decision of when should I leverage RDS or a NoSQL solution, putting an architecture in place that allows you to support greater than 1 million users. And at the end of that session, this is the architecture you'll get. So in that architecture, you see we have a bunch of web instances that are sitting in an auto-scaling group within our VPC. We have some RDS instances that are our databases, a couple of read-only guys and a master. We have some worker instances that are, of course, pulling data out of a queue, processing that data. That's where that Amazon SQS comes in. And then we have some internal instance apps that allow us to gain some visibility into the app. Then we have our Dynamo instance that's maybe doing high throughput, session state, something of that effect for the application. But ultimately, when it's all said and done, this is a fairly similar, fairly common architecture that customers build in AWS to support a web-facing application that is designed to support more than 1 million users. Do you see the security in it? It's there, and you might have missed it, because the architecture itself is pretty rock solid from an availability standpoint. But we're here to talk about security at scale, and what can I put in place to actually ensure that I'm not lessening my security posture through the course of scaling up. So there is already some security built in. For example, we had security groups. Security groups govern traffic in and out of those resources. So by default, no one can talk to a resource that you launch, an EC2 instance, for example. Using a security group, you define who can actually have inbound communication as well as outbound communication. That's in there. That architecture had that level of security already in there. We also have identity and access management, the ability to define those policies and then also define roles that you can attach to those resources that allow them to talk to some of the managed services like S3. Again, that was in there. But there was a lot of additional security built in there. Did you catch it? If I launch that architecture today, by round of applause, how many of you are going to be concerned that someone might come in and take the hard drive with all our data on it? Yeah, no one. Some of that security already built in falls on our shoulders and doesn't necessarily get depicted in an architecture diagram. Who maintains the cameras at the individual sites? Who ensures that we have actual security guards securing the facility itself and also monitoring what comes across those cameras? Who ensures that, the building itself doesn't have a gaping hole in it that allows people to walk in through a wall? All of that falls on our shoulders. All of those physical controls to secure the actual infrastructure that you're taking advantage of, which helps building an application that can meet a compliance burden, falls on our shoulders. There's a lot of security already built into that architecture. But that doesn't mean we can't make it better. So let's spend a few minutes and talk about some of the newer services that are available that we can add to that architecture to actually strengthen our security posture. So we can scale beyond 1 million users, but also do it in such a manner that we're not lessening our security posture as we continue to grow. Well, going back to what I talked about with the CAF, we have to start with identity and access management. So the first service that comes to mind is AWS Organizations. And the idea here is, as I start giving my development teams access to leverage AWS, I may want to actually segment what they're doing across accounts. And Organizations allows me to actually build an organization structure based on OUs and then place accounts into that organizational structure. And then tie something very critical to it, SCP, which is essentially a service control policy that says this particular account or this group of accounts in this particular OU can only use these services, services X, Y, Z. If I'm the security team, that's beautiful, because now, as new services are coming out, as things are changing rapidly, as I'm going back and reviewing what the security posture looks like for these new services, I have a level of confidence that my development teams haven't latched onto something that was just launched yesterday and started trying to push it into production today. Going a step further, within the account, you have identity and access management. And there, I can now say, here, organizations allowed me to have access to these particular services, and now I can build an IAM policy that now says, in regards to the services that you do have access to, these are the actions that you're allowed to perform. You can start an instance, you can kill an instance, you could modify a policy, you can spin up a new RDS instance, however granular you want to get with it. Then, of course, I have the STS service, which allows me now to integrate my policies and my roles that I've created in IAM that exist within the account that's being managed by AWS organizations and tie that or link it to my on-premises identity and access management system, whether that's AD, an LDAP directory, whatever it is, but allow users to log in using the credentials that I manage, that I control for them, that are tied to their actual employment record, and federate into the AWS environment. Given that architecture, I think we probably want to sprinkle a little of this on that architecture itself. But then we also want to start talking about detective controls. So by round of applause, who's familiar with CloudTrail? Good, good. So I mentioned earlier that everything in AWS becomes an API call. And so as your users are in the management console, clicking this, clicking that, all of that on the back end becomes an API call to actually execute the function. Wouldn't it be great if you had visibility into every single API call that got executed and who did it, what IP address they came from, the time they did it, and the result? Yeah, that's amazing visibility. By round of applause, who can do that right now for their on-premises environment? There's always one guy. You and I got to talk. You amaze me. I got a cape in my backpack for you. That's what CloudTrail provides you. An ongoing log, a trail of who's actually changing, launching, modifying infrastructure within the AWS environment. The beauty of that is you can couple that with a tool called AWS Config that allows you to actually design what your compliance needs to look like to say, hey, I'm letting these developers go and leverage AWS, but as they're using it, there are a couple of things I think I want them to do. I want them to encrypt EBS volumes, because I don't want to have a volume sitting out there that's unencrypted. Well, we can define that within AWS Config and then generate a compliance report. Show me all the volumes that are out there that are not encrypted. And then, of course, go back and talk to those guys and say, hey, I'm happy you're using AWS, but you're not using it the right way. Here's what we stipulate. From a resource level, you can take advantage of CloudWatch. CloudWatch gives us performance data from the hypervisor view. The beauty of that is most security incidents, if you follow them closely, really start with an incident. Something's changed in regards to the actual baseline of how this application performs. And as we looked into that anomaly, we determined that it was a security incident. And so CloudTrail becomes an important piece because CloudTrail gives you that performance baseline data and the ability to alert on those anomalies that you detect and detect them early on. So that way you can drive some type of response to it. Inspector allows you to interrogate your resources, particularly EC2 instances, and compare the libraries that you're taking advantage of within those resources against common known vulnerabilities and exploits. So the beauty of Inspector, again, API driven, so you can put Inspector now in line with your CI/CD development model and say, as you kick off a new build, towards the end of that build process, kick off Inspector and interrogate the instances that you've launched and allow Inspector to let me know if you're taking advantage of libraries that have exploits available to them. VPC flow logs, in my opinion, is probably one of the most important. If you get anything from this talk today, it should be turn on CloudTrail if you are using AWS already, and turn on VPC flow logs. Because VPC flow logs show you who is talking to who and whether or not that traffic was accepted or rejected. And it's just merely the flow information. So to, from, source port, destination port, protocol, time, and then an accept or a reject. The beauty of VPC flow logs, though, is you can tie VPC flow logs to CloudWatch and start to define alarms. So if I have a baseline and I know that, hey, my infrastructure is now supporting 900,000 users, I'm getting close to that 1 million, but for some reason, I'm seeing an excessive amount of rejected packets to this particular resource. I can now have a response to that alarm that could be automated. So you'll notice here, I created a threshold, excessive packet rejects. I put in that threshold if for some reason the security group rejected packet count exceeds 100 within a 15-minute window, trigger the alarm. That alarm can be merely a notification, or it could be something more complex that we do via a Lambda function. I can also take the VPC flow log data, ingest it into our Elasticsearch solution, and then be able to actually query for common things within that VPC flow traffic. Who are my top accepted or rejected sources? Who are my top talkers? Gaining visibility into the whole solution. I can turn VPC flow logs on at an individual network interface. I could do it for a subnet within my virtual private cloud, or I could turn it on for the whole virtual private cloud. So I gain visibility into how my traffic's flowing east, west, north, south now within that VPC construct. That leads us to infrastructure security. So at a resource level, as we start looking, how do I secure the infrastructure, the first thing we should probably talk about is Trusted Advisor. We've been doing this for a while now. We have a pretty good list of best practices. And Trusted Advisor is the tool to go out, interrogate your environment against those best practices, and make you aware of anything that you have currently deployed that goes against those best practices. Think of simple things that you may not know about right now, like I have SSH open to the world on an instance. Why would I ever do that? Well, Trusted Advisor would pick that up, flag it, and then give you a link to the instance as well as what the remediation steps should look like from a manual perspective. AWS, well, we'll talk about Shield. So we'll jump over to the networking side and then come back to the resources side. So AWS Shield, the idea is if you design the architecture properly, you can actually withstand the storm of a large-scale DDoS attack. And Shield comes in two flavors to support that. You have Shield Basic, which, because you came here today, all of you can have Shield Basic for free. Just tell them I gave it to you, okay? But then you also have Shield Advanced. And Shield Advanced gives you, in my opinion, probably one of the most important things, and that's access to our DDoS response team. So the ability for you to say, you know what, nothing's going down, but we're seeing our ALBs and ELBs scaling up rapidly. We're seeing a high amount of traffic to our various EC2 instance and distributions. We think we're under a DDoS attack, and I need help. AWS Shield Advanced gives you the opportunity to call AWS and say, I need the DDoS response team right now because I need help. And then we'll work with you in a war room type format to actually get through that DDoS, collect as much forensic data as we possibly can, and then actually start to tear through that data with you to determine who did it, why they did it, what the attack vector was, and then hopefully how we can mitigate it so we don't have to do this again next week. WAF is part of that solution. WAF allows you to have web application firewall rules on the actual distributions that sit in CloudFront. it's funny because I surf the deep web. By round of applause, anyone else out here surf the deep web with me? All right, there's a few of us. We'll probably have to talk VPN connections later. I need a new one. But I'll give you a guess on what the most prominent attack right now in the internet is. It's still SQL injections. And how long ago did we actually identify SQL injections and put a patch in place for SQL injections? Guess what? It's still out there. And guess what? Developers aren't writing some type of function to sanitize inputs for SQL queries, so it's going to continue to still be out there. And so what WAF allows us to do is actually put a rule in place that catches that SQL injection, shuts it down so it never makes it back to your origin. And then also provides that visibility of, hey, this WAF rule that stops SQL injection has fired 27 times today. We might have an issue. We might want to take some time to tear into this. That leads me to OpsWorks and the idea behind defining resources with a particular role and then pushing out all the relevant packages and libraries necessary for them to perform that role, as well as updates for it. This guy's a web server. He needs Apache. Give him Apache. There's a vulnerability for the Apache version. Cool, I will make a new recipe. Push this new recipe to this guy. Keep him up to date. Get me to a point where patching and updating my resources becomes a non-event. We build it once. We leverage a service like OpsWorks or Chef or Puppet, whatever your cup of tea is. But using that service, we push out the automation to update those systems. Which leads me to config. Config, I think, is probably one of the most important tools that you can have in your toolbox to actually secure or strengthen your security posture. So we talked about AWS config and the ability to actually identify when someone has launched a resource or modified a resource in such a manner that falls out of scope of what you want. What config rules allows you to do is to start to take some of those common security requirements that you probably have jotted down on a piece of napkin or a piece of paper, or maybe it's sitting somewhere in a SharePoint repository, but take those requirements and turn them into rules. Things like CloudTrail should be enabled. Yes, it should be. How do I validate that now? Things like all EBS volumes should be encrypted. Yeah, we think they should be. How do I validate that? Things like security groups attached state should not have unrestricted access to port 22. Yeah, we agree. How do I validate that? And that's where config rules comes in, because config rules now allows you to take that requirement, turn it into a rule, and have interrogation of the change happen at particular moments. You can say, because config is tracking everything that's changing within the account, you could say, when someone launches a new resource, evaluate that resource they've launched against the defined rules. So in this example, we check whether or not attached EBS volumes are encrypted. We then get a list of everyone who's non-compliant. And then I can take that list and go to those individuals and say, hey, you very smart, beautiful developer, fix this, please. Fix it now. Now. And we'll talk about this because we can go a step further. And when we talk about incident response, we'll dive a little deeper. So, we talked about controlling access to the actual infrastructure, leveraging AWS organizations, IAM to control what they can do with the services you allow them to have access to, STS to ensure that the username and password combination that they're using to get into the AWS environment is something that you still control. We talked about securing the infrastructure against best practices or towards best practices using Trusted Advisor. We talked about config. We talked about config rules. We talked about getting a visibility into what they're doing via CloudTrail and visibility into who's talking to who via VPC flow logs. We haven't talked about the sweet spot yet, because I can tell you as an ethical hacker, I really don't hack to get to your EC2 resources. I'm coming for one thing, baby, the sweet spot, the data. So how do we strengthen that security posture around data protection? So we have a few services in this arena. First being Cloud HSM. This is an actual Gemalto SafeNet Luna device that we take responsibility for power and networking, and then you take responsibility for the secured partition of it. You handle the key escrow process, checking out keys, checking in keys, capturing metadata of who had access to what keys, leveraging their actual client-side application to interface directly with the Cloud HSM appliance. If at some point you decide, yeah, we really need a Cloud HSM, but there's a big, heavy burden of every application now needing to interface with this secure client, us needing to maintain one on premises for redundancy's sake. I really just want encryption. That's really what I want is encryption. I don't want all the additional overhead. Well, guess what? We really want to take that undifferentiated heavy lifting overhead off of you and put it on our shoulders. And so we created a service called KMS, the Key Management Service. What KMS allows you to do is upload what we call a CMK, Customer Master Key. And then we use that Customer Master Key to take advantage of envelope encryption and issue data keys. So now as the services start to interface, you can actually use your Customer Master Key to control who has access to the various data keys. And we'll drill into that a little more visually. Oops. Then, of course, by round of applause, has anyone played with AWS Certificate Manager yet? Okay. I love this service because it addresses a very important pain point. I'll prove it. By round of applause, who's ever had to purchase an SSL certificate? All right. That's a lot of us. By round of applause, who's ever gotten that call day of that, hey, our certificate's about to expire, I need you to purchase a new one? Here's a bigger pain point. By round of applause, how many of us have gotten that call but weren't able to actually purchase the new certificate and get it deployed to all the relevant systems within a timely manner? Yeah. That's what ACM is designed to address for you. So ACM will help with all of that, and we'll dive a little deeper into how it does it. Ultimately, when we're talking about data protection, we want to make encryption easy and seamless. We want to put you in a position where developers, businesses within your organization have to justify why they're not using encryption. Because right now, it's so easy to turn on that everyone should be using it. And so when we talk encryption in transit, we're talking, of course, TLS. By round of applause, has anyone played with S2N? Signal to noise? No? So we actually produced a library that you could take advantage of to handle TLS communication. Embedded within your applications, skim down, smaller attack surface because of a smaller code base. Then, of course, encryption in transit, we're also talking about the VPN, the IPsec, the SSH. Encryption at rest, at the object level, database level, file system, and disk, it really depends on what your variety is. For the individual services, KMS might be a great solution. For certain database engines, when we're talking Oracle or RDS, if we want to take advantage of TDE, Cloud HSM might be a better solution. But it all depends. So let's talk about first with the TLS piece. This allows you to easily provision a certificate, tie it to a distribution. And guess what we do for you when that certificate gets close to expiring? We renew it for you and put it in place where you have it actually deployed. So fairly simple to do. You request a certificate, you add the domain name, we review the request, we handle validation, certificate's yours now. Fairly simple. I would pay, I got 10 fingers. I'd probably give pinky on my left for this. That's how valuable I find it. And I see a couple of head nods. we're giving it to you for free. So you can take advantage of ACM and help manage your certificates to meet that encryption in transit around TLS. Again, trying to get you to a point where encryption is simple. Encryption is easily deployed. Encryption is on. Encryption becomes part of your guardrails. Let's talk about KMS. So I mentioned that you get to upload your customer master key. And from there, we actually take advantage of the customer master key to do envelope encryption with the data key. The beauty of this is services that are already integrated with KMS know how to go out to KMS and say, I need a new data key for said customer. KMS knows how to give that service a particular data key, allow it to encrypt the data with that data key, and then get the key back, put it in envelope encryption using your customer master key, and then store it encrypted using the actual, using the actual key for the HSM that backs the KMS environment, HSM, HSA that backs the KMS environment. That means when I want to get at that data, that service now has to go back to KMS and say, I need the data key so I can decrypt the data. KMS then says, well, let me go fetch the customer master key so I can decrypt the data key and then give it back to you. What if you decide that you don't want us to have that customer master key anymore and you delete it? Who has access to your data then? No one. You've cut off access. And so this allows you to control who can actually see your data from a data encryption standpoint. It allows you to actually be able to rotate your keys if you choose. It allows you to pick and choose what keys are being accessed for what applications, leveraging IAM policies and rules. It also allows you to have data encryption without the heavy lifting of now writing additional code in your applications to get it done. Let's talk about incident response. So we dived into the infrastructure. We talked about how we can go protecting the data. When something goes wrong, and it will, how do we respond to it? So CloudWatch monitoring, by far, is probably going to be your first tool. Relatively low latency turnaround from detection to actually notification. So you can have your baseline, and then as you see anomalies to the baseline, CloudWatch would be the tool that will alert you of those anomalies. When you pair CloudWatch with Lambda now, you have the ability to start remediating some of those incidents in an automated manner. Let you chew on that for a second. What I just said is, by round of applause, how many of you show up and have at least over 50 alerts when you show up on a Monday morning? Yeah. For those of you who clapped, how many of those alerts are alerts you've seen in the past before? Yeah. Yeah. What if I told you that I can give you a tool to take those alerts that you have prescriptive guidance of how you address, automate that prescriptive guidance, allow the alert to fire, allow the automation to repair that alert to fire, resolve it, and then send you a notification that it's been done. That's a game changer, because that gets us to a point now where we're not needing human input for incidents that fire up. If we've seen it before, more than likely we've seen it 50 to 100 times, we should be able to actually automate the response of it. Let me give you an example. So I can go into CloudWatch events, and I could say, you know what, create a new rule. If the AWS API call for CloudTrail comes up, and that call is delete the trail or stop logging the trail, I want to do something. I want to fire off a Lambda function, again, pairing CloudWatch with Lambda to automate the remediation of this. And in that Lambda function, I want to revert those CloudTrail changes. I can add a target, and then I plug in some Lambda code. And so this is the initial function that gives you the handler to actually capture the Lambda event and then does a JSON dump of the event to indention 2. Essentially, as I look at the run of the CloudTrail events that are popping up, I could see, I don't have a laser pointer on here, so we'll go, I'm eyeballing it here. It's about 3/4 of the way down. You'll see event name, stop logging. Perfect timing. Who did it? I love you guys. So my Lambda response now is going to go back, look at the details of the request parameters. If it matches what I'm expecting, stop logging, then I want to fire off CloudTrail.start logging. Then I also want to get a notification, because I don't only want to fix it, I want to be able to go find the person who did it and put my loving hands on them in some way, shape, or form. And so I'll write an SNS topic notification that captures the relevant information that gets sent to me as well. This is what that looks like. When that notification fires, this is what pops up in my email inbox. Somebody did a stop logging event. Here is the principal ID, the access key, who did it, the account, the type of user it was, and I should be able to actually get the IP address as well somewhere in there. It's down there. To let me know that someone's done something really, really bad. Now, without automated remediation, just that alone would make me feel very, very happy. But that also means, although I got notified, there's still a window of opportunity where CloudTrail's not running. CloudTrail is that log of every single API call that's happening. It's my visibility into how the various teams are leveraging the AWS environment. This is not something that I want to be notified on and then wait for me to actually go out and turn it back on. And so using that Lambda function, I actually automate the start logging, and you'll see within a minute. So Josh Dulac came in at 10:29 and 8 seconds, initiated the stop logging. I saw it and fired off my Lambda function at 10:29 and 55 seconds. And then at 10:29 and 56 seconds, we started logging again. Incident responses that are driven in an automated fashion, that are tied to your required guardrails, that allow your developers to move faster, to build architectures that can scale to over 1 million users, while you still feel confident that you've strengthened your security posture. Gaining that visibility, removing the human element, and gaining more control via automation. So, we talked about a lot of services, a lot of things we could throw in there, a lot of salt and pepper, sprinkles. Let's go back to our architecture. So this is what our developers have deployed. What do you think we can add now to strengthen the security posture of it? What can we plug in here? Well, let's plug in some AWS Shield, so that way we can protect against large-scale DDoS events, because guess what? Over 1 million users, we can cause a DDoS by accident. Let's put some WAF in there so we can prevent that pesky SQL injection, because our developers still don't have that function to sanitize SQL query inputs. Let's put some AWS organizations in there, scope back from an SCP perspective what services our developers are allowed to use. Then let's make sure we turn on some CloudTrail. We put that CloudTrail in an S3 bucket that's fully secure. Let's add some AWS config to put some compliance rules in place, and then also some automation around those if needed. Let's add inspector to our CI/CD pipeline so we can ensure that the libraries they're using within their application don't already have known vulnerabilities and exploits. And let's take advantage of OpsWorks so we can automate our actual update and patching of all the resources within our infrastructure. I can now take this and make it a CloudFormation template. Not only the architecture, not only the VPC, but a good portion, if not all, of those security controls that now I've put in place to ensure that my developers don't tarnish the brand by doing something really, really, really dumb. Once I had that as a template, I could take it to 16 other regions. That's the beauty of the services behaving and functioning consistent. That starts with us applying the mechanisms and processes to meet those compliance programs consistently across all the regions. So now I build it once, I apply it, and then I cookie cutter copy it via that CloudFormation template to all the regions where my development and my business needs to actually go. And there's 16 of them, 44 availability zones, 77 edge locations where I can have some type of CloudFront distribution with services like AWS Shield and WAF in those edge locations, stopping SQL injection attacks, building up enough resources to block or maintain us through a large-scale DDoS attack. Now, I mentioned earlier that security is not going to be unfamiliar. Well, that's true. There are some things we talked about here that are new, that are different, but you're still probably going to leverage a lot of those tools that you're already familiar with to process that log data coming out of CloudTrail, to process that flow data coming out of VPC flow logs, to process information coming out of those CloudWatch alarms. And so those tools that you use on premises, that you have expertise around, that you have comfort around, that are part of the important security posture of tools, content, and people, I'm willing to bet a lot of them are available via the marketplace. So we've partnered up with a lot of those manufacturers of those tools and made them available to run within the AWS environment as either a virtual appliance or an AMI via the AWS marketplace. So moving those workloads isn't a holistic new endeavor. It's more so, I know how to use this tool. How do I continue to leverage it now when I move over to AWS? And how do I get this tool now to ingest some of the native logging and visibility data that the platform of AWS provides me? All right, so summary. We talked about our architecture for scaling to over 1 million users. We talked about the integrated security and compliance. We talked about that shared responsibility model, our responsibility to handle things from that hypervisor down, as well as the over 2,500 plus controls we put in place. We talked about the idea of once I build this, I can have global resiliency. I can push that same visibility and the tools I've used to give me that visibility across all 16 regions. We talked about how you can leverage tools like KMS, Cloud HSM, AWS Certificate Manager to handle the data ownership and the data privacy. We talked about how you can actually build this and then leverage it within your CI/CD process to have security part of the actual automated build. So as you're spinning out 15, 20 builds a day, you're constantly having security within that as the build process keeps going. We talked about how to do this at scale. So all of these services that fall within the managed services approach are designed to allow you to scale. You don't have to worry about how many resources are actually doing the CloudTrail logging. That's us. We'll take care of that for you. You don't have to worry about how many resources are needed to actually do your inspector vulnerability check of the resources. That's us. We'll handle that for you, and we'll make sure that it scales to meet your demand. Then we talked about how you can leverage some of the existing tools that you already are familiar with, leveraging the marketplace, and what you can take advantage of based on that short image, but additional marketplace offerings. With that said, I have roughly 3 minutes left. Questions? And please, if you have a question, there's a mic right here. We want to make sure everyone can hear. No questions. Either I knocked it out of the park, or I've just astounded all of you. Let's do it.
So do you see incorporating Lambda at the edge at CloudFront for any security practices?
So in what way would you incorporate Lambda at the edge?
One thing we've noticed is like with HSTS, enabling that for certain aspects that you don't get with like S3 and everything else like that. Some of those client-side headers and stuff like that.
So leveraging Lambda at the edge to actually,
to actually insert those headers because you don't get them.
to do the header manipulation.
Yeah.
You could. Lambda offers a different security model, right? Because you're essentially writing a function now, and then the execution of that function sits within a confined, dare I say, kind of safe box.
Yep.
And so you'll have to write logging outside of that function. You will get some logging from CloudWatch, but not the robust logging that you would get from some of the other services. So it can be done, but within that function now, you have to actually think security-minded and say, okay, I need to write these additional logs out to CloudWatch logs so I have visibility into how this function was executed, who's executing it, how often, things of that sort. And then also taking advantage of IAM policies to kind of secure and tighten that Lambda function.
Yep. Okay.
Yep. Yeah. So why would you ask me a question that I can't answer? No. So the question was, are we going to be able to use ACM certificates against our own ELB or on our own distributions, not just ELB? I think that's a great request. Let's talk offline, because if it's something that you really need in a short time frame, let's plug you in to the actual product team and let's see what we can do. It speaks to our culture. For those who don't know, 95 to 98% of all the features and services that we deliver to the platform actually come directly from you guys, from customers. And so if you have a need, let's plug in the product team. I'm pretty sure they've heard this one before, but let's see if we can help them prioritize that need. Any other questions? Yeah.
Does the inspector scan through the containers for the rules like CV and stuff?
That's a good question. Does inspector actually scan containers? Currently, no. Containers are a little bit of a different animal, right? Because inspector does run as an actual agent on the OS or on the instance itself, and containers don't actually have everything we need to run that. That doesn't mean that we won't come up with something in the future, but currently, no.
Thank you.
Right now, yes, but there are plans to possibly get away from having multiple agents. So we'll see. I can't promise. I know I hear this request a lot, and so well, next Tuesday is ambiguous, so yeah. We'll just keep going next Tuesday until it's the right Tuesday, I guess. But we should definitely talk, because if it is an urgent need, part of my job is to take that back to the service team and say, hey, we need this. Let's make sure we prioritize it properly. Yep. Any other questions? Yep. 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 Not yet. And so if you played around with Inspector in the early beta days, there were some of them that were pre-built already. And as the product actually moved for release, we pulled some of those out. I don't know when, but I know I have a sneaky suspicion just based on talking to that team that some of that's going to come back. We'll see how soon, though. All right. 50 seconds. With that said, I do want to say thank you. Again, thank you for the patience of the escalator fiasco, and thank you for giving me 60 minutes of your time. I really appreciate it.